Hello everyone. Today we'll start the basic concept of basic electrical engineering. All of you know it is a very important subject for electrical branches and non-electrical branches also. Uh, thing is that most of you fear about this subject. You can I have heard many arguments about this subject being very tough. But I have been teaching this subject for about 2 to 3 years, and I have encountered with different branches. And I have seen that people, if we focus a bit more, understand, trying to say remember the formulas, it will be very simple rather than the difficult one. And the thing is that it is also very good subject to score marks also. Okay, and that can improve your say overall first year marks. Thing is that we have say tackle this subject very differently. What we have to do is that we have to learn from the basic. Okay, so uh, it will only take 3 or 4 minutes to cover the whole say skeleton of this subject. Okay, the thing is that it is an electrical engineering subject, so it will deal with some basic electrical engineering concepts. Okay, so when I am saying basic electrical engineering concepts, I am coming from the basic point, and it will be always current, voltage, and this current and voltage, if they are combined, they will create power. Okay, and next it will create another thing, which is exist in electrical engineering, is called magnetism or magnets. Okay, so scientists, researchers from over the year, they have used this say things. When I'm saying things, current, voltage, and magnets. Okay, and they have designed many machines or many say concepts around us. Okay, and thing is that we cannot deny the existence of those concepts. Okay, we are using those say things in our day-to-day life. Okay, and we cannot exist there, sorry, we cannot deny their existence. Okay, so taking that thing into our account, okay, then we can say go one step further and learn the elements of basic electrical engineering. So now when I'm saying elements, it will come to again the basic fundamental say elements, which will be again current, voltage, resistance, inductance, capacitance. Okay, anything that is we can say experience or we can find in an electrical circuit. Okay, now if we take one step further, okay, now it will come to different electrical engineering laws. Okay, now as you have already studied physics, and say from very say school level also, you have encountered or you have heard about this one particular say law, which is called Ohm's law. Okay, now thing is that you have to take one step further and have to learn another law, which is called Kirchhoff's law. Okay, I think you have already got about these two law. Okay, now think are they, what are they? They are just a law. Okay, that the law will be followed by the electrical quantities. Okay, another you can say law or something like that, or the concept that you already know is that resistance calculation in series and parallel. Okay, so these things are we can consider in say category of law. Okay, now up to this point, what I have discussed or what I have told you with say respect to the basic fundamental electrical quantities or the basic fundamental elements. Okay, so you have already come to know about all this thing. Okay, now thing is that you have to take one more step further. Okay, and now you have to learn the theorems. Okay, so I'm literally doing one step further. Okay, now thing is that now these things you have to learn. Okay, I understand that you have not been encountered with these theorems before. Okay, now you have come to the unknown part, which are called theorems. Okay, now theorems are nothing that, just like you have got theorems in other subjects. Okay, The theorems are nothing but their way, or their a technique to say easy a complicated circuit, okay, or you can solve a complicated circuit easily with the help of those theorems, okay. So those theorems you have to understand, and thing is that you have to remember the laws and the basic fundamental say nature of the electrical quantities, okay. The thing is that by help of resistance, capacitance, inductance, voltage, current, and with using the laws of Ohm's law and Kirchhoff's laws, okay. Now thing is that you have to understand the theorems and apply those theorems, okay. Now when it comes to the laboratory of this subject, you will also have those theorems only, okay. The thing is that to ease your confusion, we can start naming the theorem. So it comes with superposition theorem, uh, Thevenin's theorem, Norton's theorem, maximum power transfer theorem, Millman's theorem, and Telengen's theorem. So Millman's and Telengen's goes in one step, say in the complex part, or it is not basically a part of the basic electrical engineering, but one can say uh, if you want, one can understand those concepts or those theorems also, okay. So those theorems will have some statement and some particular law, okay. The thing is that we have to understand those things and those particular law, and say if you have already studied this subject, then you can say you can figure out one thing is that in three particular theorem, which is Thevenin, Norton, and maximum power transfer theorem, they use the same type of say nomenclature. Thing is that you have to find either Thevenin voltage or Norton current, which are nothing but again short circuit or open circuit say nature of the current, okay, or voltage. So those things goes in common. The point of my talk is that uh, there is nothing much to remember in this particular subject, or just to learn, okay. So thing is that learning those things will make this subject easier, okay. Now thing is that as I told you this Thevenin, Norton, and superposition maximum power transfer theorem, so you have to understand one properly, then those are just a bit extension of those, okay. So I hope you can understand what I am saying, and I hope you find this subject easier as I am saying in this way, okay. And I hope I can help you to understand this subject easily, okay. And thank you for this one.